Hi and welcome back to another video within our tutorials modeling with RFM 5. Our last tutorial was about cable structures and the theory behind the calculation. This video will be about modeling surface structures. And for that, we will do a very simple example, which will be a basic concrete structure with a slab and some walls. We will start off with creating the slab. For that, we can find in the toolbar a symbol called new rectangular surface. By clicking on it, a new dialog will appear where we can define the properties like material, the thickness, and the surface type. As material, we will choose, for instance, concrete C30 by 37 based on a European standard, and the thickness will be, let's say, 300 millimeters. And then under surface type, we can choose some additional options regarding the stiffness and with that structural behavior of the surface. We can choose, for instance, without membrane tension, or we can choose a rigid one. But for our example, we don't need that, so we will stay with the standard type. With clicking OK, we can select 2 points in the graphical area to create the surface. Up here, we can change the view to the top view. This makes it just a little bit easier to snap those points. So the first node will be at 0 and 0 and the second one at 10 and 10. Then we will move the surface with an offset of 3 meters along the z-axis. For that, we use again the copy and move command, which we can find in the toolbar, or we can also find that with right click on the surface. Since we don't want to copy this one, we can keep the number of copies as 0. And in order to move it, we just type in the z direction -3 and then click OK. Now that we have our slab, we will create 4 more surfaces, which will be our walls. And for that, we click again on new rectangular surface. In the new dialog, we can keep the previous settings except the thickness. Our walls will have a thickness of 200 millimeters. And then we can graphically insert them along the edges of the slab. A great help during modeling these surfaces is if we change up here the plane, we can easily snap those points and create those surfaces. Now that we have our structure, we need also some supports. And for surfaces like walls, in order to create the supports along their edges or along the bottom lines, we can find up here the symbol called line support. And we will choose hinge ones, and then with clicking OK, we can assign these very quickly to those lines. You might notice that there is no thickness displayed for the surfaces that we've just created, although we've entered a thickness back in the surface dialog. So this is just a view setting. We can get it displayed if we go to the display menu and then choose rendering. Under model, here we can choose field inclusive thickness. Just as a hint for you, and as we can see it now in the graphical area, the thickness is rendered on these surfaces. So we are almost finished with our structure. Just for more stability, I'd like to create a column in the middle of the slab. For that, we will divide it into 4 identical surfaces so that we can get the middle node for the column. And then later, we can also apply a load on each of these surfaces within 4 different load cases. So with a right click, we can select the option called split surface. And if we enter in both directions 1, we will get 4 identical surfaces, as we can see it in this picture here on the right side. And now we can create the column at this middle node of these surfaces. So we will select new single member up here, and then as cross section, we can enter a rectangle with a height and a width of 300 and concrete as material. And then we will add also a nodal support to this column. Now that we have our structure complete, we will move on to the load cases and loads. Before we get started with defining any load case, we will first go back to the general data. The dialog for that we can open up with right click and then select general data. What I want to do here is to activate the option called create combinations automatically. So first we can determine the standard type, for example the European one, and the German national annex for it, and then we can activate this option here. This will allow us that the load combinations of the load cases that we will define later are getting generated automatically, since we have this time a couple of more load cases than usual. And with OK, we can close this dialog and start defining the load cases. So the first load case is, as usual, the self-weight, and then we will create 4 more load cases. Assuming an office building above our slab, we will choose this action category here, and let's say we call this one surface load 1. Then we can copy this one 3 more times and rename them to surface load 2, 3, and 4. And then we can assign a surface load for each load case with changing the surfaces. So we will choose the right load case up here and then click on this button called new surface load. Similar to the dialog for a distributed load, we can keep load type as force. The direction will be global z direction. As a load parameter or magnitude, we will enter here 2.5. And then we can apply it to each surface. With the loads applied, we go once again to the load case settings, and under combination expressions, we can set all possible settings for creating combinations automatically. There is, for example, the option called reducing number of load cases, which can be very useful if we have a couple of more load cases than we do right now. It allows us that the number of combinations is getting reduced to the essential. Otherwise, RFEM would create every possible combination, even it's not decisive. In our case, since we only have 5 load cases, we don't need to activate this option here. Then in the next tab called action combinations, we can define and edit the action combinations according to the standard or standard type, including the serviceability limit state and the ultimate limit state. Next, under load combinations, we can see the load combinations, which are generated automatically, and if necessary we can also edit them. Right now, for our example, we have in total 64 different combinations, as we can see it here. And then the last tab is called result combinations. A result combination superimposes the results of load cases, load combinations, or result combinations according to the preset combination expressions. If we click OK, we can have a look to all combinations up here and then check if the load cases were combined as we like to. And then we can run the calculation for our system. And since we have a couple of more load cases and combinations, this will take just a little bit longer than usual. Now we can display the internal forces, deformations, for each combinations which we choose up here. So this was our tutorial about modeling and calculating surface structures, and the next video will be about modeling 3D structures. Thank you for listening, and if you have any questions, just feel free to ask them in the comments below or on our website lubal.com, where you can find also a couple of more tutorials.